welcome to the material session of Upalsa's Career Point. This is a video for the student of class 12 on Unit 8. This is the first chapter of this unit known as Aldehydes and Ketones and the 13th video of this chapter covering the topics oxidation reactions, oxidation with potassium permanganate or potassium dichromate, oxidation with Tollen reagent, oxidation with Fehling Solution, oxidation with NaOX, that is Haloform reaction. ଏବେ ଆମେ ପ୍ରଥମ ପାର୍ଟ କୁ ଯିବା how aldehyde and ketone undergo oxidation with potassium permanganate or potassium dichromate or bromine water. For aldehyde, whenever aldehyde undergoes oxidation in the presence of acidified K2Cr2O7 potassium dichromate solution or K-minopor potassium permanganate solution or bromine water, then corresponding carboxylic acid is formed. Here the carboxylic acid form contains same number of carbon atom as in aldehyde. In the statement we have to write down, when aldehyde undergoes oxidation in the presence of acidified K2Cr2O7 or K-minopor or bromine water, then corresponding carboxylic acid is formed. Here the carboxylic acid form contains same number of carbon atom as in aldehyde. Aldehyde पाखरे जतिकी कार्बन एटम थिबो एसिडिफाइड K2Cr2O7 और K-minopor और ब्रोमीन वाटर द्वारा ऑक्सीडाइज होला परे जे कार्बोक्सिलिक एसिड फॉर्मेशन हबो ता पाखरे मध्ये समसंख्यक कार्बन एटम रहइबो. एबे एग्जांपल्स को जिबा. Let us take C3 instead of R. Then the aldehyde will be acetaldehyde and the carboxylic acid will be acetic acid. Acetaldehyde बा इथेनॉल को जेतबे ऑक्सीडेशन करिबा in the presence of acidified K2Cr2O7 or K-minopor or bromine water, then acetic acid or ethanoic acid is formed. Aldehyde पाखरे दुईटी कार्बन एटम थिला एवं कार्बोक्सिलिक एसिड मध्ये पाखरे दुईटी कार्बन एटम अछि. So in the statement we have to write down, when acetaldehyde undergoes oxidation in the presence of acidified K2Cr2O7 or K-minopor or bromine water, then acetic acid is formed. आमे एसिटाल्डिहाइड नेइथिलु दुईटी कार्बन एटम थिला एसिटिक एसिड देला सेटर मध्ये दुईटी कार्बन एटम अछि. एबे देखियो ऑक्सीडेशन विथ K-minopor और K2Cr2O7 और bromine water for ketone. How ketone undergoes oxidation with acidified potassium permanganate or potassium dichromate or bromine water. Whenever ketone undergoes oxidation, it will give us carboxylic acid. But the carboxylic acid formed here contains one carbon atom less than the parent ketone. And this lost carbon is eliminated in the form of carbon dioxide. So what you have to write down in the statement? When ketone undergoes oxidation in the presence of acidified potassium dichromate or potassium permanganate or bromine water, then corresponding carboxylic acid is formed. Here the carboxylic acid form contains one carbon atom less than the ketone. Aldehyde को ऑक्सीडेशन करले हम जो कार्बोक्सिलिक एसिड पाउथुलु सेठी कार्बन एटम समान रहउतुला, किंतु कीटोन को ऑक्सीडेशन करला परे जो कार्बोक्सिलिक एसिड पाइबो सेठी गुटे कार्बन एटम कमी जिवो. Let us come for example. R जगह C3 नबा, it will becomes acetone. When acetone undergoes oxidation in the presence of potassium dichromate or potassium permanganate or bromine water, then acetic acid or ethanoic acid is formed. आमे एसीटोन बा प्रोपानोन नेइथिलु एसिटिक एसिड बा इथानोइक एसिड पाइलु, अर्थात गोटे कार्बन एटम कीटोन अपेक्षा कमी गला. Thus in the statement we have to write down, when acetone undergoes oxidation in the presence of acidified potassium dichromate or potassium permanganate or bromine water, then acetic acid is formed. Now let us come for oxidation with Tollen reagent. Before going to oxidation with Tollen reagent, we must have to know what is Tollen reagent. The ammoniacal silver nitrate solution is called Tollen reagent. Its molecular formula is AgNH2 plus OH minus. What is Tollen reagent? एक मार्किया क्वेश्चन होता तार आंसर एतो का लेखा हले सफिशिएंट. How this tolerance agent is formed? It is prepared by adding ammonium hydroxide to silver nitrate solution till the precipitate of silver oxide first form just re-dissolves. आम प्रथम कौन करूँ ना सिल्वर नाइट्रेट को आमोनियम हाइड्रोक्साइड मिसेब गोटे व्हाइट प्रेसिपिटेट ऑफ सिल्वर ऑक्साइड फॉर्मेशन हम एडिशन ऑफ आमोनियम हाइड्रोक्साइड को आम कंटिन्यूज करवा till the silver oxide precipitate first form just re-dissolves. Then tolerance agent is formed. जो व्हाइट प्रेसिपिटेट मिली से डिजल्व है पर्यंत आम अमीनो एसिड करते होल व्हाइट प्रेसिपिटेट डिजल्व होते आम टॉलरेंस एजेंट AgNH3 plus OH minus पाइज. In this way, tolerance agent is prepared. The question is what is tolerance agent? How is it formed? Then this will be the answer. Now, how does aldehyde ketone with tolerance agent? Whenever aldehyde reacts with tolerance agent, then a silver mirror precipitate is formed. टिके रिएक्शन टिको पे मैंने भल कर लिखी नब aldehyde RCHO tolerance agent AgNH3 plus OH minus gives you 2Ag precipitate plus RC double bond ONH4 plus 2 water plus 3 ammonia. So in the equation we have to write down when aldehyde reacts with tolerance agent, then tolerance agent is reduced to metallic silver which deposits as a mirror while the aldehyde is oxidized to ammonium carboxylate. Aldehyde oxidize ammonium carboxylate को और tolerance agent reduced हो silver mirror को. Let us come for the example. Let us take CH3 in place of R. Whenever acetaldehyde reacts with tolerance agent, then a silver mirror precipitate is formed together with RCOONH4 plus 2 water plus 3 ammonia. In the statement we have to write down when acetaldehyde reacts with tolerance agent, then tolerance agent is reduced to metallic silver which deposits as a mirror while acetaldehyde is oxidized to ammonium acetate. Now, how does tolerance agent react with ketone? Tolerance agent does not react with ketone. There is no effect of tolerance agent on ketone. Ketones are not easily oxidized by mild oxidizing agent like tolerance agent or Fehling solution. So ketones do not react with tolerance agent. Now, how does oxidation is carried out with Fehling solution? Before going for oxidation, we must have to know what is Fehling solution. The equimolar mixture of Fehling A, that is aqueous copper sulfate solution, and Fehling B, that is alkaline solution of sodium potassium tartrate, is called Fehling solution. Its molecular formula is CuOH2 and chemical name is cupric hydroxide. How does aldehyde reacts with Fehling solution? Whenever aldehyde reacts with Fehling solution CuOH2, then a red precipitate of cuprous oxide Cu2O is formed. When aldehyde reacts with Fehling solution, then Fehling solution is reduced to cuprous oxide which deposits as a red precipitate while aldehyde is oxidized to carboxylic acid. Come for example, let us take CH3 in place of R. Whenever acetaldehyde reacts with Fehling solution, that is cupric hydroxide, CuOH2, then a red precipitate of cuprous oxide is formed. In the statement we have to write down when acetaldehyde reacts with Fehling solution, then Fehling solution is reduced to cuprous oxide which deposits as a red precipitate while acetaldehyde is oxidized to acetic acid. Now let us go for reaction of Fehling solution with ketones. Ketones can't react with Fehling solution. Ketones not easily oxidized by mild oxidizing agent like tolerance agent or Fehling solution. So ketones do not react with Fehling solution. Now, how oxidation is carried out with sodium hypohalide NaOX or Iodoform or Haloform reaction? All the aldehyde and ketone do not show this reaction. Only the aldehyde and ketones containing a methyl keto group can show this reaction. Both aldehydes and ketones containing a methyl keto group, that is CH3CO group, react with iodine in the presence of dilute NaOH to form yellow precipitate of sweet smelling iodoform. Hence, the reaction is called iodoform reaction. ଯେତେବେଳେ aldehyde ବା ketones ପାଖରେ ମିଥାଇଲ keto ଗ୍ରୁପ ଟେ ଥାଏ ସେ iodine ସହିତ reaction करे in the presence of dilute NaOH, then a yellow precipitate of sweet smelling iodoform is formed. जेहेतु iodoform formation हुए, hence the reaction is called iodoform reaction. In place of iodine, if other halogens are taken, other halogens such as chlorine, bromine also give this reaction. So generally this reaction is called haloform reaction. But remember that in case of iodine it will give us a sweet smelling yellow precipitate of iodoform. But in case of chlorine it does not give us yellow precipitate, it gives us chloroform. In case of bromine it gives us bromoform. So in general this reaction is known as haloform reaction. All the aldehydes and ketones cannot show this reaction. Only the aldehydes or ketone containing a methyl keto group can show this reaction. Now, for aldehyde, let us take acetaldehyde. Whenever acetaldehyde reacts with iodine, then all the hydrogen atom of methyl keto groups are substituted by iodine, and we will get triiodoacetaldehyde, which reacts with aqueous NaOH to give a yellow precipitate of iodoform and sodium formate. In the statement we have to write down, when acetaldehyde reacts with iodine in the presence of aqueous NaOH, then a yellow precipitate of iodoform is formed. Now, for ketone, let us take acetone. Whenever acetone reacts with iodine, then triiodoacetone is formed by the substitution of all the hydrogen atoms of the methyl keto group by iodine, which on treatment with aqueous NaOH gives a yellow precipitate of iodoform and sodium acetate. In the statement we have to write down, when acetone reacts with iodine in the presence of aqueous NaOH, then a yellow precipitate of iodoform is formed. Thanks for watching Bhopal Search Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time. Don't forget to hit the bell icon to get timely updatation of my new video.